Hi everyone! So in this video, we're going to go ahead and talk about something called gas stoichiometry, which is going to allow us to use stoichiometry involving gases. Okay, so we can perform stoichiometry problems involving gases by assuming that we are at STP. So remember, STP stands for standard temperature and pressure, which is a temperature of 0 degrees Celsius or 273 Kelvin and a pressure of 1 atmosphere. And we know at those conditions that 1 mole of gas is going to occupy 22.4 liters. So that is going to be the relationship that we use with our stoichiometry problems with gases. 1 mole is equal to 22.4 liters. So let's go ahead and see this in practice. Okay, so let's go ahead and try out this problem. Calcium carbonate decomposes at high temperatures to form carbon dioxide and calcium oxide. How many grams of calcium carbonate will I need to form 3.45 liters of carbon dioxide at STP? Okay, so if we think about the four-step process for solving stoichiometry problems, the first thing we need is a balanced chemical equation. So as I read through the question, it actually gives me my equation. It's calcium carbonate, which is decomposing or breaking down to form carbon dioxide and calcium oxide. And if I look, it's balanced with coefficients of 1. So that is my balanced chemical equation. Now, as I read through this question, it's always a good process to go ahead and underline what you're given, which is 3.45 grams of carbon dioxide, and circle the thing you want to find, which is grams of calcium carbonate. Okay, so we've done step 1. Step 2 is to take our given and convert it into moles. So I'm going to set up my factor label table. My given goes in the first box, so 3.45 liters of CO2. If I have liters of CO2 up top, I need liters on the bottom. And I want to get 2 moles of carbon dioxide. Okay, so this is where I have that new ratio or that new conversion factor for gases. Remember, it's for every 1 mole of a gas, I have 22.4 liters. So I've done step 2, which is to get my given into moles. Now I want to do step 3, which is using my mole ratio to convert from moles of my given to moles of my ending thing. So I have moles of carbon dioxide on the bottom, so my units will cancel out. Up on top, I'm going to have moles of the thing I'm being asked about, which in this case is my calcium carbonate. For my mole ratio, I look at my balanced chemical equation. In this case, my coefficients are all 1, so I'm going to fill those in with 1s. So my final step now is I need to go ahead and convert my moles of my final thing into moles of what I'm being asked to find, which in this case is grams. Okay, so I'm going to find the molar mass of calcium carbonate. So I'm going to go ahead and grab out a periodic table to help me out with that process. Okay, so with calcium carbonate, we have 1 calcium. Each calcium has a mass of about 40.10 grams. It might be a little bit different depending upon which periodic table you look at. We have 1 carbon. Carbon is 12.01. And then we have 3 oxygen, each oxygen being 16. Okay, so I'm going to have that times 3, and then I have 1 of each of the other ones. So if I go ahead, bring that over. Okay, so here I'm just multiplying by the number of each that we have. Okay, so then I just need to add that up to find the molar mass of my calcium carbonate. So 40.1 plus 12.01 plus 48. Make sure you type in your calculator correctly. So that gives me a mass of 100.11 grams per 1 mole. So I'm going to put that mass up top, 100.11. Okay, so now numbers on top I multiply, numbers on the bottom I divide. So 3.45 times my molar mass, and then we're going to divide that by the numbers on the bottom, which is at 22.4. So that gives me a value of 15.4. And we just need 3 sig figs here, so 15.4 grams of calcium carbonate. Okay, so now we have the U-try problem. So ethylene gas burns in oxygen to form carbon dioxide and water vapor. How many liters of water can be formed if 1.25 liters of ethylene are consumed in this reaction? Okay, so 1.25 liters of ethylene. We're asked about the liters of water. And we're assuming the reaction is at STP. So here I have my balanced chemical equation, step 1. So I have combustion of a hydrocarbon. So my hydrocarbon is ethylene. Combining with oxygen gives me carbon dioxide and water. So now step 2. Okay, from here, go ahead, try this on your own first. So make sure to pause the video and then come back and check your work. So I'll give you a second pause. Okay, so let's go over this. So we have 1.25 liters of ethylene, so C2H4. Remember, we want to go from liters to moles. That's step 2. So moles of ethylene. So 22.4 liters to 1 mole. Next, we have our mole ratio. So on the diagonal, we still have moles of ethylene. And I want to go to moles of my ending thing, which in this case is water. So now I'm going to grab the coefficients for my balanced chemical equation. So I have a 2 in front of my water. And then for moles of ethylene, I have 1. And then final step, I want to go from moles of my water vapor to liters of my water vapor. And since it specifically says vapor, we can assume that it's still a gas at STP. So it's going to be 22.4 liters over 1 mole. Okay, so let's go ahead. Numbers on top we multiply, numbers on the bottom we divide. So 1.25 times R2 times 22.4. And then divide by what's on the bottom, which is at 22.4. So go ahead, put that into our calculator. We get 2.5, but we do need 3 sig figs, so I'm going to add a 0 because that doesn't change the meaning of my value. And then don't forget your units of liters of water. So I hope that helps. If you have any questions, please let me know. Otherwise, have a great day, everyone. I'll see you later. Bye.